We've got a fun-packed video today. We recently prepared some nitromethane, so we thought we'd do some experiments condensing this with some aromatic aldehydes. First up, we're going to use vanillin. We weighed out 10 grams of our 99% food-grade synthetic vanillin. We know from experience that it's not completely dry, but we don't think this will affect the reaction. We transferred this into a 100 ml flask equipped with a magnetic stir bar. Now for our nitromethane. We prepared this in the previous video, so click on the link below if you want to see how we did this. We've got ours stored on some anhydrous calcium chloride granules to keep it nice and dry, as you can see. We weighed out 4.4 grams, which is a 1.1 molar ratio to the vanillin, and then measured out 15 ml of absolute ethanol. We added the ethanol to the nitromethane to form a solution. Then we added this solution to the vanillin in the flask, and then got it stirring to dissolve. There was no color change observed. This reaction needs a catalyst, and we wanted to experiment with using methylamine. We prepared methylamine hydrochloride in a previous video, so we used this to start with. This is about a gram of slightly damp slushy methylamine hydrochloride. We measured out 10 ml of absolute ethanol, and added this to the methylamine salt in order to dissolve it. This dissolved okay, but with a small amount of insoluble crystal on the bottom, which we assume is ammonium chloride as an impurity. Okay, now we need to convert our methylamine into the free base form which we need as our catalyst. So we weighed out 0.5 grams of solid potassium hydroxide, and we added 5 ml of absolute ethanol again. This took a few minutes of crushing and mixing in order to get it into solution. Most of it's in now, so this will do. We added the ethanolic potassium hydroxide solution to our methylamine hydrochloride solution. A white precipitate of potassium chloride, which is insoluble in ethanol, was formed. We left this for a few minutes to settle. And the clear supernatant liquid on the top is our methylamine solution, which is our catalyst. All the vanillin has dissolved in the ethanol and nitromethane now, but there's still no sign of a color change, as you can see. Let's add about 1 ml of our catalyst to the mixture. The mixture quickly starts to turn yellow, and in about 2 minutes looks like this. We set the flask up on a hot plate and with a condenser attached so we can reflux the mixture. Pretty soon on heating, the mixture turns an orange color. And then starts to turn red. We heated to a gentle reflux, at which point the mixture had turned a beautiful cherry red color, as you can see. We refluxed for 2 hours, and then for a further 30 minutes we removed the condenser in order to allow some ethanol and water to evaporate. Then we switched off the heat and allowed the flask to cool slightly. We prepared a little cold water in a small beaker with a pipette, and we added this dropwise to the warm reaction mixture as it was cooling. After about 1 ml of water was added, the mixture started to crystallize and solidify. At this point we then placed it into the fridge and chilled it down for a few hours in order to ensure complete crystallization. Here's our chilled crystallized reaction mixture. It's pretty solid, as you can see. so we set up for vacuum filtration and scraped the solid into the center. We washed the reaction flask out with about 30 ml of cold methanol, and then used this to thoroughly wash the yellow solid. And then dried the yellow product thoroughly on the pump. Here's our crude product, 7.9 grams of a bright yellow solid with a slightly orange tint. Since the filtrate was bright red in color, it's possible that the orange color is due to impurity. As a crude product, this is a 61% yield on starting vanillin. We mixed the bright red filtrate we obtained with some cold water in a beaker to see if we could get any more precipitate. The result was an orange cloudy mixture with some brown goo which sank to the bottom. We don't know what this is, but it doesn't resemble our product, so we discarded all of this. To recrystallize our crude product we used methanol. We started with about 50 ml of hot methanol in a beaker and added the crude product. We kept adding methanol and heating the mixture around boiling point. Nearly there. It took about 150 ml to dissolve all the solid, at which point we then covered the beaker and then left it to cool down. Here's the result an hour later. A mass of yellow crystals in the liquid. Very pretty indeed. We set up for filtration once again, and filtered the crystals. We left them on the pump drying for about 30 minutes to make sure that they were completely dry. Here's the final product. 6.5 grams of bright yellow fluffy crystals with the texture of a fine sugar floss. They fluff up and so the volume is large compared to the actual weight of solid. This is a final yield of 51%, which is on the low side, but is comparable to some of the more reputable reports we could find. During the workup and both filtrations, we noticed a large amount of red filtrate, and generally everything turned red. We wanted to know if this was a reaction byproduct, or something else. Here's some ice water, and a small amount of the yellow crystalline product. There's no color change, and the yellow crystals are insoluble, just floating around in the mixture. Now here's some hot water at about 60 degrees C. And some more product. This time we've got the red color. The yellow crystals seem to be slowly dissolving and creating very intense red color in solution. We're going to take a guess here and suggest that the red color is actually a decomposition product, and that water is reacting. One final test. Here's a little acetone in a small beaker. We dissolve a little of our product in it, and it forms a nice yellow solution. Now here's some ice water. Let's add the acetone solution of the product. No yellow precipitate, but an intense red-colored solution again. We're not sure, and this could just be some bizarre solubility behavior, but it seems possible that the product is quite unstable, especially in contact with water, and especially when in an organic solution. This could explain why our yield is low, and give some clues as to how could work the reaction up to give the better yield. Just in case, We're going to keep our product very dry and store it in the fridge until we find a future use for it. Stay tuned for more videos.